Welcome and thanks for joining us. My guest today is Lakshmi Ashok. She is the Vice President for Enterprise Management Services at Leidos. Lakshmi, good to have you back.
Good to be here too, Tom. How have you been?
All right, very well, thanks. And as we've since spoken, cloud continues to advance in the federal government. And I wanted to ask you what you're seeing in terms of cloud adoption as agencies build up from the original email collaboration tools to the higher order things. We're hearing about AI and RPA happening in the cloud, whatever that means, edge computing and all these digital services. What are you seeing?
Yeah, I think I'm seeing some fairly positive uptake in the adoption of cloud. And you're absolutely right. It's gone from use cloud as a data center to, hey, let's use cloud for all these neat services. And so, I will start off with giving some citizen enablement services as an example, right? We've got, for example, I applied for a passport online 2 months ago, and I got it within a few weeks, no issues, right? That's really good self-service. To applying for a visa or applying for some healthcare benefits, so that's citizen enablement services. On top of that, you've got big data crunching and AI/ML functions too. You see in the healthcare organization where they're crunching, gazillion bytes of data to figure out a strain of a particular virus and then to see what antidote works for that. So these are some use cases on big data and AI/ML. And then you've got, mixed reality, virtual reality situations where in remote locations, we've got to train folks or we've got to do some maintenance. We use cloud for that too. And finally, you were talking about edge solutions. There's so many cases that we at Leidos see itself, right? From arming a warfighter at the edge to act quickly based on information, right? Information instantaneously. Or giving a border security agent the right set of tools so that they can figure out whether somebody crossing over is a good actor or a bad actor based on biometrics that can be processed right there within a handheld system. Or even, FEMA, for example, sending out drones ahead of time in a disaster zone to see if things are safe for people to go in and then work it. Or UAS, sending UAS to survey areas for targets. And then let's not forget the medical field where people deployed now are wearing wearables to figure out what their health status is. So many examples of how cloud has been adopted for those higher order services and also to give us a really good customer experience.
So that implies a couple of things have changed for the better. Mm-hmm. One is the bandwidth and speed of lines. Like if you mix VR with local reality, you really have to have no latency or it won't work or people get seasick or whatever the case might be. But also when you mention number crunching and all of these different types of applications, the cloud computing facility itself is more adaptable. It can emulate more types of environments. Even supercomputing can be now effectuated by by what cloud service providers offer. Mm-hmm. So they have a much wider range of offerings in terms of just the compute interface than they did maybe early on.
Absolutely, and more services. So you see like a plethora of cloud native services. And going back to supercompute, you have compute at the main cloud, but then you're also looking at compute at the edges now and processing at the edges so that we do not have to have data move over a whole network. The processing is done right there and you have quick access to information right there. Yeah.
Right, and so I guess then the implication is we're seeing edge computing devices that emulate the cloud. Just as you have the cloud emulating different styles of computing for whatever is needed, you also have an edge that becomes basically a clone of the cloud, but at the edge.
Yeah, absolutely.
Got it. And so that changes the equation then, data center versus cloud. It's becoming one kind of architecture that might be deployed in different locations. All right, and so that gives rise to the question of, what do we do first, or what do we do next, maybe, more accurately? It was kind of obvious to get email and Exchange servers and all of this stuff out of the agency, a lot of administration, a lot of expense. That was an early streamlining. What are some of the metrics that agencies should use, the thought process, to say, what do we do next of this higher order cloud deployment that'll get the best payoff?
Yeah, and when I think about metrics, there are a few that come to mind. I would like to start off with customer experience. Today, it's all about the customer experience. And cloud, just as we talked, is ubiquitous, right? It's everywhere today. So people have easy access to it. And developers have easy access to it. So building a really good customer experience is a metric I would go by. Second is speed. Speed to getting these applications developed and deployed, especially taking light, so many policy changes are happening, right? And how do you make sure that the applications directly reflect the changes in policy as quickly as possible? That's the second thing. Third thing, security. So definitely security is a metric. Gone are the old days where we had our data centers and we had the perimeters to secure and everything in the data center would be safe. Now we've got to rethink security. We've got to rethink a cloud security from a zero trust perspective, right? And here's where we in Leidos are doing a lot of solutioning around zero trust, especially as it comes to cloud. The other aspect I would think of is cost. So thinking about cloud, and cost is a double-edged sword. So thinking about cloud as just another data center and lifting and shifting applications to cloud is not going to pay off. So carefully looking at the applications that we need to build out into cloud, looking at what really belongs in the cloud and moving it there gets you cost efficiencies. So these are some of the metrics. I would also say interconnectivity between the clouds are a great way now to share services between agencies. So as we come up with some of these services, think about how to utilize, how to leverage this interconnectivity.
Yes, and that leads to another area where, to tie it all together, kind of this optimization and artificial intelligence, and that is into the automating of your cloud operations themselves.
Yeah.
Because people realize, like you say, lift and shift.
Yeah.
And yes, you've got the operating expense model now, but it's a high cost one. It's a high cost for operating. Whereas if you can balance your workload by the second, really, that you're paying for in the cloud, nobody can do that manually. The cloud itself is the object of RPA and AI application.
Yeah. Agreed. And there's I've seen many implementations of automations via AI within cloud, especially for the operations side of it. So think about looking at workload scheduling to say these workloads are going to be used the most at this time of the day or at this time of the year or whatever it is, and then can be shut down later. Right? Or then the other thing I'm looking at that I'm seeing that we implement today is anomaly detection. So looking at past data and recognizing a pattern of events that can lead to a failure or reduction of service availability. And then being proactive about that so that next time we see a similar pattern, coming up with remediation for that. So anomalies. Root cause detection is another thing I'm looking at. Finding that needle in the haystack as to why something happened. And we use AI for that today. Workflow optimization. So we talked about customer experience, right? How many times do I call to get something, to get help on something? And really literally have to either wait online or punch different numbers. So we're using AI to help through that workflow process to say, okay, this is the path to least resistance, and here's what the workflow should look like. And finally, the other thing I would really emphasize the use of AI, which we are doing today, is looking at security breaches, right? So collecting logs from various components in your cloud and other elements, and looking again for these patterns that lead to data breaches or security breaches and avoiding them in the future. So these are some of the ways we're using AI for cloud operations.
And that speed of breach detection is really a key point. At least two major regulatory agencies have a similar gambit going on for the respective industries that they regulate.
Yeah.
And that is much faster reporting of when they know something of a material nature has happened.
Exactly.
I think Homeland Security has that going on, the Securities and Exchange Commission has that going on, and maybe some others.
Yeah.
And agencies aren't too swift at that.
Yes.
Organizations aren't really, historically. So maybe that's one of the great applications is, yes, the dwell time might have been for 6 months, and you discover it, then they want to know within an hour in some cases, not 3-4 days, or if
Hopefully
you decide
within
at all.
minutes. And hopefully we shouldn't wait for an event to occur, for an outage to occur before saying, oh, there's a breach. With some of the AI that we've been working on, at Leidos, we can in fact detect the pattern and say, oops, there's a breach waiting to be happening here. Yep.
Okay, and let's get back to the lift and shift question. I think agencies that have lifted and shifted have already done so.
Yeah.
But what have we learned about the better ways to migrate workloads to the cloud since the early days when you just lifted and shifted?
Yeah, and there are, there's a number of things to consider when we migrate applications to the cloud, right? For example, time constraint. We talked about lift and shift just now, and the time constraint has been the number one driver to lift and shift to the cloud, where the data centers are closing, and there's a mandate to say, move to the cloud. Okay. Obsolete code is another area as to why we're moving to the cloud: cost and security. So I see 3 fundamental patterns in app migration today. One we covered, our favorite lift and shift. The second is moving the app over to the cloud. And here what happens is sometimes if the application is really old, then we have to build a brand new technology stack in the cloud and move the application over. So bring in new CI/CD pipelines, bring in new technologies, stacks, and everything else. And then the third way of doing is something I prefer, redefining the business logic and coming up with a great customer experience, which almost invariably means start fresh in the cloud, start building the application fresh in the cloud. And there's a number of things to take into consideration when we do all this, right? So taking a look at the developer perspective. So if I'm developing in the cloud, I want access to all the latest and greatest cloud native services. But from an agency perspective, I want to make sure as a CISO or as a CIO that these native services are secure. And so what we offer is, a catalog of these native services that have guardrails, security guardrails on them. So that's the first thing I would like to talk about.
That's a big catalog.
That is a big catalog. Absolutely. The second one, I think we've chatted in the past, Tom. This is all around processes. So we've got technology that's moving ahead, and we've still got processes that are slightly lagging behind. Think about the change control process, the ATO process. And so we really need to revamp some of these to get to where the technology is. We're looking at Leidos, we're looking at security solutions like ATO acceleration, for example, right? And these become critical when we migrate to the cloud.
I just want to pause on that.
Sure.
That's really critical because in the Agile era, you're constantly refining the application. You find out something that might on Wednesday and you want to have it fixed by Friday.
You have a new build, yeah.
But you don't want to have an ATO that goes 10 Fridays from now to get it approved.
Exactly.
And so you need to build in the inheritance of the ATO, the assurance that what you inherited continues, all simultaneously with whatever change you're making.
It should be in your build pipeline. Exactly. So that gets done as you're building.
And I'm guessing the third issue is security.
Absolutely. So especially as we move these old pieces of code, obsolete code, we want to look for vulnerabilities. And so we're doing static and dynamic analysis continuously. And we have a good build cadence so that we're continuously and often looking for these security vulnerabilities and building code based on them, right? Combating those vulnerabilities. So these are some of the things I would emphasize as we're looking at app migration. There's one more key factor, right? Data. Data is the all-important critical factor, and applications are hugely dependent on the data that drives them. Getting a good data strategy is key as we're migrating applications.
And let me ask you about that data strategy, because the data has been a source of expense in extraction costs. And yet you need data everywhere, at the edge, and you need it in the cloud, and sometimes you need it in your agency to find out what it is you found out in the cloud, what the application discovered. So what are the elements of a good data strategy?
Yeah, I'll start with policy. I think looking at the business logic is the first thing we want to do when we start to formulate a data strategy. Looking at data compliance requirements. Sometimes there's security compliance as to where the data may reside, especially in edge situations. You don't want the data to traverse a certain place. Right? There's retention policies that we need to consider. So policies is something we start with. Architecture is the next thing. So build a modular data architecture to start off with. Look at whether you want to use a data lake, you want to use proxy, you want to use a data mesh, some of these. And then look at retention policies. I've seen that in the agencies in the past that I've worked with, almost all data has been around for years, for eons, in fact, and that leads to a lot of cost, storage costs especially. So look at the data retention policy to say, all right, this data we need to retrieve at a certain speed, and 7 years out or 7 years behind, we can perhaps archive that data. So look at those strategies. Also look at the security of the data. Does the data need to be encrypted? What kind of stuff? How do you encrypt this? At what levels does the data need to be encrypted? Look at whether the data needs to be at a certain position. Can it be distributed? Does it have to be close to the edge? Does it have to be at the data center? And things like that. And then start looking at the data itself. What kind of transformation does the data need to undergo? Like cleansing of data, enriching of data once you have a data model identified, looking at securing the data further. And so all these strategies, all these thought processes go into figuring out a good data strategy.
With respect to storage, it could be that, and I'm asking, if you replicate a data set at the edge because it's used there, but it's also in the cloud, that might be a less expensive option to maintain the data set in two locations than it is to move it back and forth over cloud transport. And the only thing you have to move is the synchronizing when something changes.
Absolutely, and you don't have to move all the data. So if we have things that process data at the edge itself, then maybe only some relevant data needs to be sent back to the cloud. So these are things that we need to look at as we architect.
I guess in Homeland Security in particular, a lot of the applications of screening and so forth, the data doesn't get retained at all, and don't accidentally retain it. It's non-compliant to do that, and it's also
Exactly.
expensive.
Exactly, and some have policies that says this data will be deleted after a certain in a certain time period. So those are the policies that I was talking about. Look to what policies exist, and then architect for those policies.
Yes, because if you don't have the right business rules built in, you could inadvertently retain data that's supposed to be destroyed, or vice versa.
Yeah.
And nobody did anything deliberately wrong, but you just simply didn't have the logic.
Yeah.
Correct. Okay. And before we go, I wanted to touch a little bit more on edge, because we talked earlier that the edge might replicate the cloud in architecture and in functionality.
Right.
And what are you seeing agencies actually do there? Because some define edge as we've described it, which is a small cloud somewhere, a rack even, a physical rack. But people also talk about it in terms of sensor data gathering and generation, but not really processing.
Yeah, it's all of the above. And we're basically looking at the edge as putting computing power near where the data is, right? For multiple reasons. And one is to be able to respond quickly, to compute and respond quickly at the edge. Two is to save those data traversing costs, right? And so some of the considerations, again, when we're talking about edge, is architecture. So think about getting your edge infrastructure modular and look at all the edge cases. You just mentioned a few edge cases, right? So how does your architecture meet those different edge cases instead of having one-offs for each case? We want to avoid it as much as possible. The second thing is, edge is, to talk about another use case is it can be used in disconnected operations also. So don't always assume that your edge is going to have constant network connectivity. How do you plan for that? How do you architect for that scenario? Similarly, think about the networks you can utilize, with the advent of 5G. Do you want to use that? Do you want to complement it with another solution like a Wi-Fi? These are other items to consider. Security is huge at the edge because not only are you securing the endpoints, but you're also securing the identity that's accessing the edge. You are securing the compute, you're securing the network, you're securing the data. And you want to look at not just data encryption, but you want to start looking at things like privacy enhancing techniques and confidential computing, for example. So again, look at security from a holistic zero trust perspective. And lastly, I would think, look at the higher order services, look at employing that at the edge because you've got the compute power, you want information quickly. So use things like AI/ML to give you the information you need immediately. We talked about AIOps, cloud operations. So again, use AIOps based on AI to look at performance of your edge devices and make sure they're performing as they should be and that there is no breakage or interruption to operations there. So these are some of the considerations I would say we need to apply towards the edge.
Well, as always, we've covered a lot of ground. So I thank you. My guest has been Lakshmi Ashok. She is Vice President of Enterprise Management Services at Leidos. I'm Tom Temin. You're watching Federal News Network. Let's go back to the studio now for more of the Cloud Exchange.